Uh, Hello everyone. So today we are going to solve few questions from Codeforces round 956, which was a Division 2 contest. And let's start. So first question is array divisibility, which was a very simple question. So in this question you will be given an integer and you have to create an array uh, which is beautiful and with subject to k. And what does beautiful means is essentially uh, an array is beautiful if uh so suppose the array is a1 a2 up to an. It is beautiful with subject to an integer k if we take all the elements whose index is divisible by k and their sum is also divisible by k. So 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 given an integer n, you have to create such an uh, array. And this is a fairly very simple question because all you can do is, if given n, you can essentially write numbers from 1 to up to n. So if you take any numbers which are divisible by any k, uh, and some those number, it will those numbers will essentially be divisible by k only. So for example, if k is equal to 3, then the numbers you will be choosing are 3, 6, 9 up to n. So sum of all these numbers will definitely be divisible by n. So this was a fairly simple question. You just had to print all the numbers up to n. Moving on to the second question, which is corner twist. This was slightly interesting question. So in this question, you are given an two grids. You are given two grids, and in this question, you are allowed one operation. So what could you do in an operation? You take a sub rectangle or subgrid, and so you are given two grids. So in any operation, what you can do, you take a sub-rectangle of a subgrid or the entire rectangle itself, and you choose the corner elements. And what you can essentially do, add add two add 2 to one of the diagonal elements and add 1 to another diagonal elements, and take modulo 3 of those. So it is guaranteed that both the grids have numbers from 0, 1 and 2 only. So your task is, given a grid A with this setting, you have to convert this grid into, you have to determine whether you can convert this grid into grid B or not. So let's focus a bit more on this operation. So suppose you are given a grid. Suppose you are given a grid, so say something like this. Suppose this is your grid A. So what happens when you perform any operation? Take a subgrid and perform any operation. Suppose I choose this subgrid and I add 1 to these diagonal elements, add 2 to these diagonal elements. So whenever you do this operation, notice that for every column and every row of your subrectangle that you choose, you are essentially adding three to those columns and to those rows, if you see it clearly. So after this operation, this column will look like 0 1 2 1 1 1 2 2 plus 2 modulo is 4, modulo 3 is 1, and this will become 0. So whenever you perform any operation, what essentially happens is you are adding 3. So you are adding 3 to all those columns and rows. So basically nothing is changing. So now to check whether you can convert grid A to grid B, what you can do, you take the difference of both the grids modulo A. So if you take B minus A modulo 3, you will get another grid which is basically the difference between both the grids. And now in this new grid, all you have to do is check whether all the rows and all the columns are divisible by 3. If the sum along all the rows and sum along all the columns is divisible by 3, then you can convert grid A to grid B. And to show that we can easily do this, I'll show an example quickly. So for example, let us take the last test case over here, which is, give me some time to write this down. So it is 0 0 0. This is the A grid and the target grid is 0. This is the target grid. So if we take the difference over modulo 3, then the difference grid will look like, so 0 minus 0. So first column will remain. Oh, sorry, I made a mistake. So the second grade doesn't look like this. The B grade looks somewhat like this. Okay. Now if you take the difference between take the difference B minus A, then it will look like, and 2. 0 minus 1 is minus 1, but minus 1 modulo 3 is 2. So the new grid will look like this. So now what you can essentially do is, you can convert grid A, convert all 0 grid of dimension 2 cross 7 into this grid using 4 operations. But now what I want to prove it out to you is that even greedily, what you can convert 0 0 0 grid into this grid. How? So what you can do is, so if you have a 0 0 all 0 grid, so what you can try to do is greedily convert this grid into the above grid. So what you do, you look the first uh, top left element which has not been set to its correct value. So here in this case the 0 is not set to 2. So what you will do, you will choose this sub rectangle and such that the value of this person is set to 2. So after this the rectangle will look like this, and now this person's value is set. Now you go to the next element trying to set it out, and eventually it will turn out that you will be able to you will be completely able to set this entire grid to whatever value you desire, you want it to set, whatever you want to set it to, because horizontally we know that all the elements sum up to 3, and horizontally all the elements and vertically all the elements set up to sum up to 3. So due to this property we'll be able to if you just follow this procedure greedily, we'll able to convert the all 0 grid to this difference grid, which is same as converting the A grid to B grid. So all you had to check in this question is whether after taking the difference of the grids, whether you can uh, whether all the rows and columns are divisible by 3. So moving on to the next question, which is have your cake and eat it too. So in this question, there are 3 people who have different value associated to a cake, but the sum of cake pieces, and but the sum of the values for all the 3 are this is same. So essentially what you had to do is you had to distribute the cake among the 3 people, contiguous segments to the 3 people, such that each of them gets their at least 1/3 of their perceived value of the cake. So let's move on to the question. So we have 3 arrays A, B, C, which is basically the values of the cake. Uh, Values of the cake for all Alice, Bob, and Charlie. So what you have to do, you essentially have to associate some contiguous segment of cakes for all the 3 of them, such that each of them receives at least 1/3 of the perceived value, 1/3 of the total total value of the cake, as per their as per how they perceive the cake. So now, what approach we can think of is, let us assume let us assume that uh, maybe Alice is the one who will be given the. So there's no point in wasting any cake, because we can always allocate the entire cake to all of them, basically making two cuts. So now the question is, where do we have to make these two cuts? So let us assume that Alice gets the piece which is in the middle. So if Alice gets the middle piece, then the first half can either go to Bob or Charlie, or the second half can go to the other person who wasn't selected in the first part. Uh, I'll call it Charlie or Bob. Okay, so all you have to do is run so you take the array of values for Alice, and you run a two pointer approach, and you run two pointer approach, and the moment you get this sum to be greater than one third of total, you check whether you sorry you check whether giving this part to Bob and giving this part to Charlie is giving the satisfactory condition, or doing giving this part to Charlie and this part to Bob is giving the satisfactory condition. If yes, then you set the answer. You collect these indices as the answer, and break. Or else, what could possibly happen, that instead of Alice being in the center, Bob could be in the center, or Bob could be getting the centerpiece, or Charlie could be getting the centerpiece. We are fine with all the three of this, because once you run a two pointer approach considering Alice is in the middle, you will take order and time to check all the possible cases, and similar is for Charlie and Bob. So you would need to do this process like three times over order of n. And another thing what I would suggest is having prefix sum arrays calculated for A, B, and C, so that you can find the sum of this part and this part, or even this part in constant time, if you have the prefix array stored with you. So prefix sum array stored with you. So this takes care of the uh, third question. And now moving on to the fourth question. Swap dilemma. So in this question, you are given two arrays, and we have to make them equal. We have to check whether we can make them equal or not. So in order to do that, so you are given two arrays, A and B, and you have to check whether you can make them equal or not. But in order to make them equal, you are only permitted one operation. So you take L and R in first array, and P and Q in second array, and swap AL and AR, BP and BQ, such that the difference between L minus R and P minus Q is the same. So this is what is expected of us to do. So how do we go about solving this question? We have to check the feasibility. So if you concentrate on the operation which we are permitted, so essentially we are only allowed to swap elements from both the arrays which are at equal distance from each other. So for example, L and R, P and Q. So if these are like four elements, if L minus R is equal to 4, then P minus Q should also be equal to 4. So essentially we can only swap elements which are equal distance from each other. So now let us assume that we plan to swap A and B in a given array, and let us assume there are x plus y plus z elements in between them, such that all the x elements are smaller than A, and A is smaller than all the y elements, and all these elements are smaller than b, and all these elements are smaller than z. Okay, so after swapping a this to this, let us observe what happens to the number of inversion pairs. Note, remember, a number of inversion pairs is number of elements such that a larger number of pairs such that a larger element is comes before smaller elements. So when we swap this, since a is going at the end, so no, a number of so because these x elements are smaller than a, and since after a goes at the end all these inversions are fixed, so number of inversions due to x are decreased by due to x are decreased by number of inversion decreased by x. But since y and z are greater than a, and a is going even beyond these numbers, so the number of inversions are increasing by y and z. Similarly, when b comes in the beginning, the number of inversion due to x are increasing due to x are increasing. Number of inversion due to z are decreasing, but because b is greater than y, the number of inversion due to y are increasing. So, and depending on whether a is greater than b or b is greater than a, there will be additional increase or decrease in number of inversion pair. So total number of change in the inversion pair will be 2y plus minus 1. So now, if you notice, no matter how the elements are distributed, every time the change in the number of inversion pair will be number of change in the inversion pair will be equal to 2 times number of elements between a and b plus minus 1, which will be a odd number. So if you are given array a and array b, array a and array b, so if the number of inversion pair in this array is divisible by 2, and in this array is not divisible by 2, so what will happen is, if you perform any operation, the number of inversion pairs will change. The parity of the number of inversion pair will change. So after performing this operation, this won't be divisible by 2, and this will be divisible by 2. This is what will happen if you make a this is what will happen if you make a swap in the respective arrays. So due to this uh, so due to this uh, uh, all you need to do in this question is count the number of inversion pairs, and and ensure that they have the same parity. If they have the same parity, you need to check that after sorting, both the arrays are same, because you need same elements in both the arrays. So all you need to do is check number of inversion pairs, and if they have equal parities, if they have equal parity, uh, then check if the like both the arrays have like same elements, or easier way to check it is sort both the arrays and check whether they are equal, or what however you want to check whether the elements of two arrays are equal. And if their parities are same, if the parity of number of inversion pairs is same, and both the arrays have same elements, then you are good to go. Then you can essentially make the arrays same. If they aren't, then you need then if the elements aren't, in all other cases you cannot convert the arrays into equal arrays. So that was the fourth question. So that's it for this video.